Hello, everyone. Welcome to our session. Today, we will discuss something that concerns everyone this year. I am, of course, talking about isolation. While most of us were self-quarantined in our small apartments, our today's guest did something much cooler. Along with his colleagues from all around the world, he isolated himself in the middle of the Arctic on board of the research vessel. Dr. Markus Freiem is an atmospheric and ice chemist who joined the British Antarctic Survey in 2008. He investigates snow, ice, and atmosphere interactions. His work helps us to learn of past climate and improve predictions for how the polar regions will respond to future climate change. Dr. Freiem has led 15 field projects in Antarctica, the Arctic, and South America. His most recent expedition took place this year from January to June, when Dr. Freiem joined the international mosaic team on board of RV Polarstern in the central Arctic Ocean during a field season disrupted by COVID-19 pandemic. Hello, Marcus. Thanks for joining us.
Yeah, hello, Elia. Thank you for inviting me to the program, and thank you also for the very nice introduction.
It's my pleasure. How are you there? How's the weather?
Yeah, British weather, overcast sky. This morning was pouring rain, but so far so good.
At least you're not in the Arctic anymore.
That's right, and I have to say we returned already in June, so I have been already a couple of months back adjusting to life at warmer latitudes. But the memory is still fresh. Yeah.
Let me start with the most important question of all. Since you've been both in Antarctica and in the Arctic, who's your favorite, polar bears or penguins?
Oh, I prefer the penguins. You can, they're much nicer,
I see. And have you seen many polar bears this season?
So we were early in the season, so in the winter going into spring, being lodged into the central Arctic, so far away from the open ocean where the polar bears like to hunt, actually. So we have seen only two during our leg. Our colleagues who followed us later in the summer, they were fortunate enough to see many more, actually. Yeah.
Great. Well, I think we should move to more serious topics. And could you please tell us what was the purpose of the Mosaic expedition and how is it different from other Arctic missions?
Yeah, that's right. I mean, Mosaic, it's a fantastic project. It's the multidisciplinary drifting observatory for the study of Arctic climate. And it's a year-long expedition into the central Arctic Ocean. Its purpose was really to closely observe all the pieces of the grand climate puzzle to really make sense of ongoing climate change. And those pieces of the puzzle will include the ocean, the sea ice, the snow on the sea ice, the atmosphere above it. And the goal was really to be there and sample that system and understand better the processes, biogeochemical processes and those around the ecosystem in sea ice, for instance. And by understanding better those processes, we hope then to improve existing climate models, improve the representation of those processes in the models, which eventually gives us a much better chance to predict more accurately future climate in the Arctic and actually also beyond. So this is like the grand goal of this very ambitious expedition. And how was it different, you're asking, from past missions? Of course, the very first to do something similar was Fridtjof Nansen, the Norwegian explorer, more than 126 years ago, when he set off with a wooden ship, the Fram, to use, in fact, ocean currents to drift across the Arctic Ocean and do measurements and prove, in fact, that the ocean currents carry you across the North Pole. So this was more than 100 years ago, and then there were more expeditions coming along. And I mentioned here, for instance, the North Pole ice flow stations run by the Russian Arctic and Antarctic Research Institute in St. Petersburg. And they started as early as 1937 and went on and until now, 2015, in fact. And that's when instruments and people were in fact put on an ice floe, drifting with the ocean currents. More recently, it has been harder, of course, to find solid ice to deploy such a station. So then ships, research icebreakers came into play. To mention is there the Sheba ice station in the Canadian Arctic in the late 1990s, and then N-Ice, a Norwegian project just 5 years ago. And then Mosaic came along, which is arguably the largest scientific expedition to the high Arctic. I mean, more than 600 scientists involved, and then measuring year-round the coupled climate system and the sea ice. Quite an amazing opportunity to come together as an international science community to do that. So that in that sense, it's a unique project.
And how long was the planning stage of this expedition?
In fact, I would say the originators of the idea was certainly 10 years to start from the first idea, finding a ship and getting the various research institutes involved. I myself got involved only like maybe 4 years ago through a meeting in Prague, which was part of the Arctic Science Summit Week. Yeah.
And if maybe some of our viewers, maybe me myself, would like to participate in the next missions, what should we do? When should we apply?
Yes, you should get in touch with us and tell us a little bit about your expertise and how you would be able to contribute. And well, it's not only sciences. There was a media team on board. In fact, there was a film crew from a German film production company who would take footage for a documentary. Yeah.
I think I can cook. How big was the crew?
So on Polarstern, in fact, we were a total of 100 people, 60 scientists, 40 crew. And of course, one of the most important jobs on the ship is the cook, in fact. Because you have to keep people happy.
Sure, that's important. Why is it necessary to isolate scientists in the Arctic for a year or several months? Wouldn't it be easier to use drones instead to collect the data?
Yeah, that's a very good point. And I must say, many of the instruments we use, I mean, they're complex instruments, often heavy, and they need often the scientists who develop that instrument to be there, in fact, to do a good measurement. Then also there is the whole issue of collecting samples, like collecting a snow sample from the sea ice surface or drill an ice core. There you have a person actually doing it, or collecting a water sample, lowering a bucket into the ocean and collect water from a predefined depth. There again, you need a person. Or you go higher up above the sea ice using balloons, etc. You need someone to operate the winch. So we cannot do really without people and with these more complex instruments and experiments. However, there is some equipment which can be now with modern technology can be run on autonomous platforms such as buoys. So they are lodged into the ice and they can send back water temperature, for instance. We were operating on our leg also UAVs, unmanned aerial vehicles, so small airplanes, and you can put on, equipment the size of a chocolate bar, I mean, very small equipment, which could then measure meteorological parameters, wind speed, temperature, etc. So those can be run more autonomously. But again, I think for such an ambitious measurement program as we were trying to carry out, you still need really the people in the field and work together and do actually the work in situ, on the site.
I see. And what about satellites? Have you used them?
Satellites, of course, are a very important component of the whole measurement program, because you can imagine with a ship or a drifting ice station, you're measuring just one point in a vast region. And then you have, of course, to make a judgment how representative are these measurements. And so you need to get a picture of the larger region. And there, of course, satellites are very important. Thanks to them, we have, in fact, a time series of sea ice since 1979, where we know now how sea ice extent and even thickness has changed over time. But again, to understand the satellite measurements, you need the ground truthing. You need someone on the ground who's saying, okay, this is the measurement, and that's what the satellite should be seeing. So part of Mosaic was also to do the ground truthing of satellite measurements.
Gotcha. How long did it take to adapt to life and work on board of the Polarstern?
Yeah, that's a good question. I mean, you see, it's quite a remote place, and maybe I should say, once you board a ship, you know, it's like moving into a new home, you know. And the first home was actually the Russian icebreaker Dranitsin, when we were leaving northern Norway in late January this year. And yeah, you just move into your cabin. You're usually sharing with someone else you have never met before, so you have to get acquainted. Then you learn about the most important thing, what is the schedule for meals. That's important not to miss that. Yeah, and then meetings every day. Yeah, and then you formally, after a couple of days, you have like the routine on the ship. Of course, our time on Dranitsin was much longer than expected. Instead of like 2 to 3 weeks, we ended up spending 5 weeks on the ship. So we knew it quite well in the end. Yeah.
And why was it? Why was it took so long?
Yeah, so I must say also that it was the very first time it has been attempted to using a diesel-powered icebreaker to go to a latitude like of almost 89 degrees north in midwinter. This has been the first. And so of course, unsurprisingly, the sea ice was very thick. Every evening during our evening meetings, we were looking at sea ice maps. We got sent by a satellite phone, looking for cracks in the ice we could use to go quicker north. But for many, many days, there was no cracks. It was just thick ice. And the further north we went, the slower our progress. I remember the frustration one day was we would make like 10 kilometers north, got stuck, had to turn off the engines because it was no use, wasting fuel. And then the next day we had drifted back 10 kilometers. So 0 progress.
Wow, unbelievable.
It was at a point also quite uncertain if we're ever going to make it to the position of Polarstern, because at the same time, we saw on these maps, of course, also the position of Polarstern. And at some point in time, I think mid-February, it seemed like as if Polarstern was accelerating away from us. It was frustrating, of course.
Wow. And how has the coronavirus affected the mission?
Yeah, it had a big impact, of course. The original plan was leave end of January, reach Polarstern in 2 weeks, and then do 6 to 8 weeks of measurements, and then get evacuated by Russian airplane, by Russian Antonov plane, beginning of April, back to land. Well, we arrived already late and thought, well, we'll have just another 4 weeks. And said, oh, this is very short given the amount of effort we have put in. But it came all differently. Corona spread all of a sudden. There was no more airplane available. The crew, there was even like a positive Corona case, I believe, but there was no more crew to fly the airplane. The airports got all closed down. So no more airplane. Then next thing would be maybe a ship. Then rules have changed also. So on the Russian ship, for instance, on Dranitsin or Fedorov, they wouldn't allow anymore any civilian passengers on board. So they could not come for a rescue. And other ships were at the time still in the southern hemisphere, so it would take them months, in fact, to go north. So that was a huge impact, which caused also quite a bit of tension and all this uncertainty. When are we going to get back home, etc. And that lasted about a month, I would say, until with a lot of effort from RV and collaborating institutes, a plan was put into place to get us out and give us a timeline by when, more or less.
I believe it was quite hard for the team to experience such an uncertainty. And what ways to raise the morale have you used?
Yeah, it's like, that is, as I say, the team was growing together during this kind of hard time out there in the polar night. There was not only work, of course, there. We had also some get-togethers, and the photo you see there, in fact, was the farewell party for the exchange team, beginning of March. So we had arrived, 100 people. We had moved in on board of Polarstern, and of course, our colleagues from the previous leg, they had to leave their home, move over to Branitzin to go south. And then we had like a barbecue actually on the sea ice, which was amazing. I like to experience it. It was fairly cold, I must say. Everyone was huddling quite close to the fire. And we had some hot wine, and then experiencing also like it was clear skies, as you can see, and the twilight was like now getting stronger by the day. But that was an amazing moment, and then talk also to some Russian colleagues who were then moving off and leave us very soon.
Great. In your opinion, what was the most ambitious experiment during this expedition?
Yeah, I would say in general, it was very ambitious to aim at like maintaining measurements year round, right? To maintain such an comprehensive measurement network, so and instruments operating on the ship, on the sea ice, in the vicinity of the ship, but also further away. They had put something into place called the distributed network. So within 10 and 20 kilometers, they had these autonomous buoys, and to operate it under very challenging winter conditions, for example. I think that was overall very ambitious, and I think we were successful. Of course, there was challenges, but it was definitely a success. And I'd like to say an ambitious undertaking was what you see here in the foreground. And so in the background, Polarstern, further in the back, Branitzin still there, waiting to take off in the next few days. And in the foreground, you see 2 orange tents. And in fact, they're housing a tethered balloon. It's a fairly small balloon, like 10 cubic meters filled with helium attached to a tether. And that balloon could carry a number of instruments and up to 1,000 meters above the ice. And we knew, I mean, the area is like undersampled, not many data, but even less so higher up in the air. So it was really like a goal to probe as often as we could the lower atmosphere right above the sea ice. And so we're trying to but the wind had to be calm enough, right? So during a storm, it was impossible. But as soon as it calmed down, and this was a calm day, actually, we were able to launch the balloon.
And what was the coldest temperature during this mission?
Yeah, I believe we were experiencing that during our leg, so the leg 3, which was January through June. And it was sometime around March, a temperature of minus 42 degrees Celsius was recorded.
It's just usual Tuesday in my hometown of Novosibirsk in Siberia.
You're not impressed, I see.
No, not at all. We've discussed already the planning stage of the mission, but how long it will take to interpret and publish all the data?
That will take years. Of course, now we have finished the field part of the project, but now everyone is busy processing the data. Also, a lot of samples which have been taken are now being shipped home to the home lab, and they need to be analyzed, and that can take up to a year to do like very sensitive chemical analysis of snow and ice samples in the ocean water. And then we will gather in workshops or at conferences to discuss the results and then start writing up the papers. So it is a process over several years. And it's also like the look into the future, that the outcome of this Mosaic project will like keep a couple of generations of scientists busy, in fact. That could be on the order of 10 to 20 years at least, and this data set will be talked about a lot, and because it will be such a step forward in understanding the Arctic environment.
Great. And could you please tell us about the public engagements of the Mosaic team? What formats did you use?
Yeah, so some of you may have actually followed the expedition using the Mosaic app, where we posted daily field logs. So every team on the ship got to write a little expose on the experiment, or we were interviewing the cook, or what was happening on the bridge. And so you get a nice overview. And the app was also giving position of the ship, where it was currently, also the weather conditions at the time. So that was a nice way to engage in real time, actually, almost. Then I mentioned already the filmmaker, the film team filming us various experiments. And then also coming back now, events like this one tonight, where we are able to talk about the work we have done. These were the main ways we engaged really with the public.
Markus, what was the most difficult thing for you personally during the expedition?
Yeah, I mentioned already, I think the uncertainty in the beginning. I think the feeling that we may never reach Polarstern, and that we would go 5 weeks one way, don't get there, go back 5 weeks, 10 weeks out there without having achieved anything. I think this was a worry, which felt like, well, there's a lot of effort for nothing. It all came differently then, but this was a big worry. And maybe the other challenge, and you see here also on the picture, is the sea ice dynamics. The sea ice was incredibly dynamic for the time of year. So in March, we had lots of storms, early breakups of the sea ice. So every morning we looked out of the window, the sea ice surface looked different. We had like, open leads, open water, it would freeze over, and then the ridge. And so in the beginning, we were like panicking, saying, how can we reach our instruments? And our power, when we had power loss, so we had to reestablish power. But in the end, we worked well together and learned to live with the environment, to accept it as like your daily challenge. And we said, okay, there's a big crack, let's get on, and then take maybe a long detour using these kind of ladders to go across the ridges. So we were really learning to live with the environment. Yeah.
And what was the most exciting part, besides, of course, meeting the polar bears?
Yeah, I would say, again, to live out there, spend a lot of time out there on the sea ice, to experience firsthand the environment we are studying and really understanding. It's been only like 7 years that I'm working on sea ice, and every time I go, I realize, it's very dynamic, and it's very heterogeneous. It's like quite a complex surface to understand. So I found this quite exciting. One night we went actually out and took a camping trip on the sea ice, and that was actually very nice to be away from the ship. So we would be a group of 10 people with Nansen sleds and take a tent, a few sleeping bags, and the rifles to guard against polar bears. Would go away like 3 kilometers, and then behind the ridge, out of sight of the ship, and then spend the night out in the cold. That was amazing. An amazing experience. Yeah.
Great. And what do we know today about the climate in the Arctic that we didn't know, let's say, 20 years ago?
There's been lots of progress, of course, in the science. And I mentioned already the satellite data record, and that's ongoing. And that tells us that there is a trend in losing sea ice, or less sea ice, thinner sea ice, younger sea ice. That's being confirmed by the ongoing measurements. Then we understand also a lot more about feedback loops, that whatever happens in the Arctic, where there's very significant warming, has an impact on atmospheric circulation, and then impact further down in more southern latitudes where more people live. And then the way back it works as well. So when you have a change in atmospheric circulation, it feeds back onto the Arctic climate. So these feedback loops, we are more and more aware of them, and how they are key to the climate change, and how it is important to understand these feedback loops. I mean, you heard about the late freeze onset in the Laptev Sea, maybe, which is right now in the media. So the warm summer in northern Siberia, and there's a lot of heat stored in the ocean you can't get rid of very quickly. So the freeze onset is delayed now. So it's the latest on record. So again, there are all these links. And finally, in terms of science, also, I think that the concept of looking at sea ice as like a lid of the ocean, and in winter there's no exchange and nothing, that's also being revised, because of course there's energy exchange, but we have realized now there's also exchange of trace gases, greenhouse gases, or small particles which may have an impact on climate. And knowing that there's something, we are taking now a closer look with our experiment to understand that better and improve the models. And
what are the current predictions? Will we see the ice-free Arctic Ocean this century?
I think that will be the case. I mean, there's still some uncertainty when exactly, but unfortunately, we're on a trajectory for an ice-free Arctic in the summer.
Is there something that all of us can do to avoid such a terrible result?
Of course, any changes will take time, so the system will notice that difference. I think everyone can look how they can change their personal lifestyle, learn also natural sciences to help maybe the science or inform policymakers what they could do differently. I think everyone can contribute in a small way, and everyone will be different.
Markus, please be honest. Do you miss the Arctic already?
Now, looking at the picture, I must say, yes. It is a nice environment. I mean, of course, I enjoyed the summer now and the warm weather, but sooner or later we'll be going out again, either to the Arctic or the Antarctic to carry out another field project.
Great. Thank you, Markus. I think it's time for our audience to join this discussion. And we have a lot of questions already, and I encourage our viewers to post their questions so we could answer them. So the first question from our viewers. Markus, have you always wanted to be a scientist?
No, I think the first thing I wanted to become was a journalist.
Really?
Yeah, I mean, it was sort of a trajectory. I liked the natural sciences. I studied physics and chemistry later on, but early on, I think I was more interested, like to write about other projects, and that changed over time.
So the world lost a great journalist, but found a wonderful scientist and Arctic researcher. Second question from our viewers. Did you ever imagine that you would have such an experience in the Arctic?
Oh, not at all, no. I think that the special thing about this was also like to go there in winter. You know, most of the expeditions and field projects are usually in summer, be it the Antarctic or Arctic summer. It's easier to get there. But really a time of year where there are a lot less observations and a lot less expeditions because it's so difficult is really the winter time. And that was amazing. And yeah.
And could you please tell us about your projects in South America? What did you do there?
Yeah, so this was quite some time ago, but obviously when you have climate warming, it's first the smaller ice masses and glaciers react first, like a fever thermometer of Earth, basically, right? So we're observing loss of alpine glaciers, but also those in the tropical Andes in South America. So there was a French research program looking at the glacier mass balance in the high Andes. And I was a young student, and we were camping there on the ice, setting up an automated weather station and trying to understand how the climate change works, and the warming works, and how it changes the ice volume and the runoff. And for the people there, it's very important because they use the runoff from the glacier for irrigation and for hydropower generation.
Another question from our audience. From all of your expeditions, what was the most unusual experience for you? Maybe not necessarily scientific, but personal?
Well, unusual, I think like just a great experience in general is like being on those ships a long time with a rather small group of people is the way how you then are able to work together. I think it's a great part of that whole science. It's not only like your instrument, the work. It's really like also like how to get along with each other and across several languages and cultures, and then plan a camping trip or a field experiment together. So I've been I mentioned 7 years work on sea ice. So we started out with a winter experiment in the Antarctic, and we are now in touch over the years doing projects together, and actually not only colleagues, but actually close friends now.
That's great. There was an article in the New York Times earlier this month about some sensitive topic, I would say. So the article said that some female members of the team felt uncomfortable on board of the Russian icebreaker due to some dress code issues. Have you heard about it?
I think I was not there on board. I just read the article, and so I cannot comment on that really firsthand. But it is true that, of course, there's not more and more female scientists and also female crew members, but traditionally it has been a male domain, and I think there's some learning has to happen on both sides. So it's all about communication, and I think they were a bit caught out, you know, on some events, but overall I think it was all right.
But is it still a boys' club like in the times of Fridtjof Nansen, or things changing?
I think things are really changing. I mean, just if I look at our leg, we had these 5 science teams, and each one of them had a female leader. So we have now, you know, female postdocs and PhD students, but also moving into leadership positions, and that's fantastic.
Every time I have a chance to talk to scientists, I always ask them one question. If you had a chance to meet with Amundsen or Nansen, what would you ask them?
Yeah, I mean, if I met Nansen, yeah, I'm fascinated by his story. You know, I would just ask him again how he got this idea, you know, to use the ice drift, and how he could convince everyone surrounding himself to get funded, you know, and then get out there and find the support to do that crazy project.
Yeah. And speaking of these great researchers of the past, who do you like the most? Robert Falcon Scott or Amundsen?
You know, as a German, I'm in a neutral position. You know, that it's different. Scott, I see him as the scientist. I had he took his own chemical laboratory to Antarctica, and I was fortunate enough to see that, actually. Very amazing. But then Amundsen was unbeaten, you know, in terms of logistics and careful planning, and actually managed to come back alive as well. So he was very well, and he learned from the people living in the high Arctic, you know, what they do, and then he basically took their methods. So that's very, very smart. Yeah.
Great. A couple more questions from our viewers. How did the time you spent in the Arctic change your perception of everyday things?
Well, it's a difficult one to answer.
Yeah, it is difficult.
So every day, of course, we had our daily routine on the ship, right? But it's quite unusual compared to your daily life back home. Obviously, the food is cooked for you. Well, we had to do our beds, that's fine, you know. But then someone cleaned our room, and well, we had to do our laundry. So very simple things you don't have to do, really. I think once I came off a field project and I forgot the PIN code of my credit card because I hadn't used it for a couple of months. Things like that, you know.
Baby steps, baby steps.
Yes. Or maybe another one is also that the Polarstern, of course, is quite a luxurious ship. I mean, you have hot showers, we had a sauna, and so, you know, after a long day's hard work, we were able also to relax a little bit. But I think when you come back, you appreciate a little bit more also, like the luxury when you go back home, you know. Especially, I think, be able to walk in a park and see some green things.
Sure. One more question from our comments section. How did you become involved in the British Antarctic Survey?
So yeah, I mean, I was at the time a postdoc in France, and then, and of course, I mean, the British Antarctic Survey is a well-renowned institute, and they were looking at the time for an atmospheric chemist, and I applied, and they they gave me that position. So that was already 12 years ago, and that was a start working here in the UK.
Did you start by studying polar science, or did you specialize later?
That's interesting. I think by training, I'm a hydrologist. So I work with the water cycle and physics and chemistry of it. And at some point, since I grew up in the Black Forest, so we get like snowy winter. So I like the snow. I moved then topic-wise into frozen water. And then it's basically, you find a PhD project and then one project follows the other, and you find your own specialization, which was then actually the chemistry of air and snow.
There is a question from, I think, very environmentally concerned member of our audience. How do scientists and crew of the vessels try to avoid causing damage to nature and minimize their impact to the environment?
That's a very good question, by the way. Yes, absolutely. I mean, we are in the central Arctic, and we are at that moment in time the biggest polluter. I mean, we are burning diesel fuel to keep the engines going, to make fresh water, etc. So there's no way around it because it's a diesel-powered engine. But of course, there were strict rules regarding the environment. So, for instance, all the equipment on the sea ice was supposed to be taken out again, so nothing left behind. Also, like handling fuel on the sea ice or any hazardous material was strictly regulated. So if there was a spill, like refueling a skidoo or generator, you were supposed to pick it up with a spill kit. And yes, I mean, there were strict rules and to minimize the impact. I mean, we definitely had an impact, but given the circumstances, we tried our best to minimize that. Also, impact on the wildlife. Of course, I mentioned the polar bears and that we had these rifles. Of course, shooting a polar bear would be a tragedy, right? And it was only meant as a very last resort to save a life. Yeah, it's clear that we are visitors in their environment, and so we have to respect their life, their environment, and respect them.
Yeah. And what is your opinion on the use of nuclear power in the Arctic? Does it have less negative impact than fossil fuels?
Well, it depends what you look at. I mean, of course, nuclear power has zero carbon emissions, but has other problems, which are not solved yet. And I think I'm not an expert in this, but I can only, from my really my personal view here, is before you put a nuclear power plant somewhere, you don't control also like the waste. I'd rather not to. I mean, these are really very sensitive areas, and you know, an oil spill or like a nuclear spill, etc., has the consequences are even more severe than further south, maybe.
Yeah. And what is more comfortable for scientists, to be on a nuclear icebreaker or on a regular diesel icebreaker?
I cannot say. I've never been on a nuclear icebreaker. I've seen them on pictures, and I know
they look great.
They're huge. Yes.
Could you please give some advice to students and maybe school kids who are wondering whenever they should choose science as their field of expertise? Where should they start?
Well, I would just recommend in general, I mean, choose a hard natural science, you know, physics, chemistry, biology, and start with the basic principles, the fundamentals, and then you move on yourself, and then you pick your specialized topic, and then you can, you know, start on this scientific journey of exploration, basically. But don't shy away like from like, you know, some hard mathematics or so. Find a good teacher, go through that. Oh, chemistry. I know I had a pretty bad chemistry teacher back in high school, and I told myself, no, I never want to do any chemistry, and look where I am now. Yeah. I think be persistent, and the hard way is maybe not, is often actually a good way.
Another question from our audience. Is there any chance we could see an inhabited city in the Arctic in the nearest future?
Yeah, it's hard to answer. I mean, in a way, if you wanted, like, we were a little city, you know, a small town on a ship moving. But I mean, it's an ocean, right? I mean, yeah. I wouldn't know. I hope we keep the place pristine, actually.
Yeah, and if anybody wants to live in the Arctic, they should move to Norilsk. Markus, what is your favorite book?
Obviously, on the ship, I was reading the Farthest North. I mean, the Fridtjof Nansen's book, and that was very fitting.
Yeah. And what kind of music do you like to listen during your expeditions?
Yeah, that was interesting. So we had, I mentioned already, you know, some parties and get-togethers, also with the crew, having a barbecue either on the ice or on the working deck. And that was always an opportunity also, like, to listen to each other's music. And that were great evenings, you know, so everyone brought their own. And I remember also, like, some Russian folk tunes, or, like, you know, a little bit more modern touch to it. That was quite nice, and everybody was dancing. So I quite enjoy that. I mean, I think we call it world music, you know, so from different places, not necessarily from Germany. Yeah, so that's my personal taste.
Did you have a chance to communicate with your family and friends who left on the continent? And did you miss them?
Oh, of course, yeah. Missed my nephews back home, and the rest of the family. So we were in touch with them, well, through email and text, of course, but then we had satellite phones, and especially during that time of long wait, Avi gave out free phone cards, so you get some extra minutes, you know, to talk, and that worked quite well, actually. You know? So, like, every week or so, short call, and then we found out, of course, that they're not much better off than we were. You know? I mean, they're locked down in their houses. I think we had a more exciting life than they had.
Yeah, indeed. So the polar research really came a long way in the last 100 years. No more real isolation.
The polar research has changed a lot, really. I mean, we touched on that already. It's not anymore male-dominated, and communication has improved a lot. So even if you stay a whole winter somewhere in the Arctic, you can speak to your family. And then also, yeah, so that made it a lot easier to withstand. I mean, in the old days, people went for 2 or 3 years, right? And this, yeah, and this time, well, we were 5 months. It was a long time, right? I mean, but yeah, still shorter. Yeah.
What are your future research plans? What do you plan to do next?
Yeah, of course, we will spend quite some effort now here at the lab to analyze our samples. But then we are already in touch with project partners. We met actually through Mosaic to do a new project either in the Arctic or even in the Antarctic. So I think one big project, and many will be involved in, is to do something similar in the Southern Hemisphere, in the Southern Ocean. Again, a multidisciplinary drift station, and this will take years to plan, but I mean, it would be nice to do that kind of study also in the Southern Ocean, which is poorly understood with some aspects. Yeah.
Great. And this was the last question. Thank you so much for joining us, Markus. It was a pleasure to speak with you.
Thank you, Leah. Fantastic. And thanks for the questions. All very great. Thanks.
My pleasure. And I would like to thank the UK Embassy in Moscow and Theory and Practice for hosting such a wonderful festival.